I'm not gonna take it easy on my haters. Not gonna take it easy on my haters. Hey. No, into the 7. I miss that. Damn. Oh my God. What you gonna say? Hey, oh my God. Hey, watch it for the bay. Hey, oh my God. I just do the lane. That's some. Oh my God. Chasing all the goals in it. Oh my God. Ain't nobody trying to tell us shit, but I be grinding. We be stepping. We be stepping. Data structures and algorithms Data structures and algorithms. Okay. You say, all I ever do is just control your life. But how you gonna lie like that? Yo, what's good, yo? What's good, yo? What's good, my brothers? How y'all doing? Hello, bro. Yo, what's good? Abdul, what's that name? Abdul Shahid? Abdul Shahid, what's good, my brother? How you doing? Abdul Shahid. Your name is nice, bro. You have a dope name, my brother Abdul Shahid. I'm trying to fix this stuff real quick so that we can start the stream. Today we're doing lit code. Obviously, we're gonna start with data structures and algorithms. After that, we can rush to do projects. It will depend, but we're gonna have a long ass stream today. I know most of my audience are from India, so it's probably like 10. I think it's 9 p.m. that side. I understand that. You get it? So if you guys ever sleep, thank you guys for always being there for me. So go and sleep and sweet dreams, my boy. But yeah, other than that, we're still gonna be streaming. So let me jump on stream real quick. Oh my God. Hey, just do then hey, oh my God. Okay, let me make sure everything is right. I'm gonna push me to the edge. Oh my God. I'm gonna put my book just right here because I use this book to read and write as well, right? So what's the time? Is it 6? Almost 6 p.m. Okay, not bad. Alright, so this book is to jot down the notes of what I'm gonna be doing. So I'm gonna be doing valid Sudoku. Yo, what's good? Hello, how are you doing, brother? How's life, man? Hi, how are you doing? I'm trying to fix this stuff. Just give me a second, okay? Let me fix these things real quick. Oh my God! Hey, welcome to the hey. Oh my God! They trying to tell me shit. Okay. Oh my God! How are you guys doing? How many days it takes to learn Java? Bro, there's no definitive date, man. I feel like for you to be good at something, you just need to put in the 10,000 hour rule, bro. Like 10,000 hour rule to become a master. So that means you need to put at least 5,000 hours. So do your division. I think it will be like maybe 6 months or 8 or 9 months. It depends. So yeah. 5 days? Jesus. Somebody trying to learn Java in 5 days, crazy work. Bro, you making my day, man. You funny as hell for that, though. You're not learning Java in even 6 months, bro, because you'll not get good. You need to put in work, at least 9 months. So I put 6 months as the goal, and then 9 months as like, yeah, if you don't make it in that time. So it's super hard, bro. Bro, I know JS Python only, but product-based company wants Java for DSA. What should I do? Learn Java. You can like spend 2 months practicing, or maybe 1 month for Java. For interviews, right? For interviews you don't really need like a lot. For interviews you just need to understand the basics. I think that's it. For interviews you need the basics. You don't need all that shit. Oh my goodness. I'm just trying to add this to the settings. Yeah, for the interview, bro, you just learn Java basics for the interview. You don't really need a lot. Okay, what's going on here? Failed to process. Okay. Oh my god. Hey, push me to the edge. Oh my god. I'll be walking to the leg. Oh my god. Java Spring Boot. I think I should have made a DSA. Oh no. Okay. This I'm just setting up something real quick. I'm almost done. Just give me five more seconds. I'll be done right now. Yep, just like this. And here we are. I think I'm done now. I can just close this off and then close this off as well. Go here, go to the channel, click on here. Yo guys, like the stream, brothers, like the stream. If you are joining the stream right now, just like the stream. Let's get it. Let me turn this so that I can show you guys my screen. Okay, we're good. Let me close this off. And boom, Notion. We don't really need it now. Okay, we're good. What are you guys saying? From India? Brother, Java's my first language. Oh, that's good then. That's good. Have you done any interviews yet? Bro, I haven't done anything. Chronicle of Ages. Bro, motherfucker, let me put it. Bro, where have you been, man? Where have you been, my brother? Where have you been? Where have you been at? How you doing, man? How you doing? I haven't done any interviews, haven't applied for any job. Like, I haven't done nothing. And I have this inferiority complex where I feel like I'm not good enough. I need to actually start applying for jobs for sure. I'm installing Arch for the 8th time. Naughty from India was good, my brother. How are you doing? How is life? Yo, listen, Chronic of Ages, I'm gonna apply for jobs starting today. Like after the stream, I'll start applying for jobs. I wanted to start on 1st January, but better late than never. But never late is better. Okay. Let me now quote Drake. So today we are doing valid Sudoku. We did product of array except self, but somehow we did not understand the prefix sum and stuff. So let me just, I think we're going to go through it, prefix and suffix product today. Let's see, I'll go explain. Let's just see. This is algo. Yep. We're going to try to understand this real quick. You need to design a data structure that can efficiently search for words based on both a prefix beginning and a suffix ending. Is that what we are looking for really? Okay, let's look at the Java process. Iterate this for words less than this string, the starting word, and then the length. No, that's not what we want for sure. We want the product of. Okay, let me just open ChatGPT. I think ChatGPT really can give us the correct answers. Okay. Let me just say. Alright, so allow reasons. Okay, cool. Let's say, bro, what? Disconnect. Why is it trying to use my phone, bro? Why is this shit trying to use my phone now? Yo. Okay, yo, brother. So, alright. I think it's cool. Now. I think it's cool. Okay, so let's just say. Alright, so I'm solving a problem involving product of array except self, a lead code problem in general. I want you to explain for me the optimal solution, which is O of n, where we're going to be using suffix and prefix to get the products. But somehow I don't understand the entire suffix and prefix issue. So just elaborate for me and explain it to me like a 12-year-old, but make it very easy to understand. All right, I don't want to do too much. I think dictation is better than typing. Do you guys dictate or you guys type? I think this is okay, bro. Let's strip the mystery. No magic, no because just today's problem is actually valid Sudoku, but I want to understand this one better first before we can approach the problem of today. All right. All right. So let's see. Let's strip the mystery out of this. No magic, no because just multiplication and clear way to avoid doing the same work twice. The problem in what the hell is this? What the hell is this, bro? Oh my god. Hey, by the way, I reduced the price for channel membership because somebody yesterday told me that the channel membership is too expensive. Yeah, that's true, bro. Not everybody can afford that. You feel me? So at the end of the day, we gotta lock in, my brothers. Alright, so let's see. I'm hoping everything is fine. Just multiplication and clear way to avoid doing the same thing twice, the same work twice. You have a list of numbers, so 1, 2, 3, 4. For every position you want to multiply all the numbers except the one sitting right there. So the answer is 24, 12, 8, 16. Why? I think we already know this, right? So this is slow. For every index, loop again and multiply everything except me. That's all of n squared. Works but is lazy and gets yelled at in interviews. I've been doing great. I've been a bit busy for the past few months, but I'm back now, looking back in coding for the new year. For real, bro. Speaking of the new year, I really don't know what I got going on, but I have at least a big foundation going into the new year. So that means hopefully this is going to be our year to land our first job. Fingers crossed. You get it? It could be an internship actually. I am going to be applying for internships starting today. And then going forward, I'll also add projects and stuff. Right now I'm working on like a interactive chat application. It's not really interactive. It's just going to be real-time chat application. I just want to explain how I want to learn how to use real-time communication with WebSockets. That is it. And then the last project will just be using microservices so that I can break it down into using things like Kafka, using things like API gateway, Nginx, reverse proxies, and other stuff. We shall get into all that. But for now, let's just stick with what we have. So let's see what's up. For any index I, how have you been, bro? I see you've been consistently streaming, man. Keep up the consistency, bro. Man, I appreciate you, bro. Yeah, I haven't been very, very consistent, but I'm trying to get as consistent as I can get. You understand? So I appreciate you for sure, man. I appreciate you a lot for that. So let me just try to understand this. The core idea, this is the key. For any index I, the product of everything except me is the product of everything to the left of I, the product of everything to the right of I. Now, let me just give me a second. Let me try to understand it. So the product of everything except I, that means of everything to the left of I. So let's say if I, why am I, I'm using my book that you guys can't even see what I'm writing. So I think it's better for me to use eraser.io or maybe Excalibur. Yep, I think it's better to use Excalibur. And yeah, we can have like, let's say we have an array 1, 2, 4, and 6. Now, what's the multiplication of 1, 2? The output, this is the input, and then this is the output. Let's say the input is 1 times 2. This is going to be 1 times 2 times 4 times 6. This is 24 times 2 is 36, if I'm not mistaken. Wait, 38 or 48? Am I really confused, bro? I think it's 48, right? Because 2 times 4 is 8. 8 times 6 is 48, right? Yeah, 48, because 8 times 5 is 40. Okay, let's go. Let's assume we are now on 2. When we are on 0, this is 1, this is 2, this is 3, and then we have now we are on 1. That means we're on 2. We cross out 2, and let me change this. We cross out 1, we cross out now 2, and then we start multiplying everything except 2 itself. So that is 1 times 4 times 6, that is going to be 24, and then we cross out 4. Now we deal with 2 times 6, that is going to be 12, and I think that is the answer, right? Now no, that's not the answer, because if we cross out 6 now, if we cross out 6, then we consider the rest, which is 2 times 4, it will be 8. Okay, so something like this. Now we need a better method. Rather than looking for every index, we need to look for just, let's assume I is now this, right? So that means this version is going to be 1, 2, 4, and 6. Let's now assume this version is what we need. We need I to be in 2. So if I is equals to 2, that means we start from here coming down. Let me change this color. That means we start from here and then we separate them. So on the right of this, right, from the right up to here and from here up to here. So we have the product of elements from the left, right? I think this is the left and then this is the right. Product of all elements on the right to I, and then the product, left to I, and then the product of elements from the right to I also. We need to keep track of that. What's the question? The question is here. The question is here. Let me show you. The product, as you can see, given an integer array nums, return an array output where output I is the product of all elements of nums except nums I. That means product of array except itself. That's what we want to solve. Now, we've solved it already with brute force solution, but we are trying to solve it with the, how do I call it? Oh my God, how do I call it? With the optimal solution. So yeah. Now, what elements are to the left of I? Given I is 2. That means we have 1 and 2. That means we multiply 1 times 2. That's product of all elements on the left, which will result to 2 is equals to L, right? Product of elements on the left. And then product of all elements to the right of I. Now, are we really considering I itself? No, we're not considering it, right? So that means we just multiply 6 times 1, which is 6. That means on the right, we have 6. Now, we have right is equals to 6. And left is equals to what? Left is equals to 2. What sense does this make? I don't know. Let's just see. Product of everything to the left of I, product of everything to the right of I. Okay, that's it, the whole trick. We'll give those two parts fancy names. What's up, bro? You look nervous, bro. I'm not nervous. How am I nervous? How am I nervous? You guys say anything. How am I nervous, bro? I'm not. I'm not nervous. I'm too cool, bro. I'm keeping my composure. Composure. Now, prefix is equals to the product of numbers before you. Suffix is product of numbers after you. Okay, now think of keys standing in a line. 1, 2, 3, 4. I understand that, my brother. Left of 3, 1, 2. Right of 3 is 4. So product except self of 3 is equals to 1 times 2 times 4. So you never multiply 3 self, you just ignore it. Now we build the prefix products. Prefix means if I start from the left, what's the product before me? Okay, we'll create an array. Prefix I, that means we need to consider that number, which is I, right, is equals to products of all elements before I. Then nums is equals to 1, 2, 3, 4. the prefix will be 1126. Huh? Wait. Why? Because position 0, we have 1, nothing before it. Yes, nothing before it. Yes, it will remain 1. Prefix of 1 is equal to 1, just 1. Yes, makes sense. Now, what about 2? Is 1 times 2. Yes, will give us 2. Yes, makes sense. Then on 3, we have 1 times 2 times 3, which is 6. But given we have I at what? I at 4, right? I don't know. How are we? Wait. Before we go ahead, where are we getting this from? So we are considering 0, 1, 2, 3 like this, and then we are taking 0, 1, 2, 3, and then we are multiplying. If this is 0, then we leave will be 1 because there's nothing before it. Yes, starting from the what prefix, that means the left, and then 1, we're taking 1. How is 1 also 1? And why is 1 remaining 1 rather than it becoming 0? I don't know really. I have no idea completely. Let's continue. Prefix never includes nums I itself. Now we build the suffix. If I start from the right, what's the product after me? Suffix, okay? So let's assume we have 1, 2, 3, 4. That means the suffix will be nothing after it. Okay. Wait, now I'm getting it. What about trying the 30-day posting your ongoing projects and finished projects on all platforms? That's my goal for the next month, but I'm gonna do it mostly on LinkedIn. What about trying the 30-day posting your ongoing projects and finished projects on all platforms? That's my goal for the next month. That's a great idea, by the way. That's a great idea. Now, you know what? I just have a tendency of perfection. I don't know. I have that problem. I want my things to be perfect. Like before I put myself out there, I want the project to be complete. Then sometimes I rush it. Then I start including AI like to just help me code out most of the parts, and then I call it a day. That's now the problem. So that will put a lot of pressure on you. But if you're okay with that, go ahead and do it. I think that's a great idea to put yourself out there. And I'm also doing it on YouTube, so you guys can see I stream every single day, right? So let's get it, man. Let's see how it goes. Just always ping me, okay? Just let me know so that I can check you out as well. Let's go. Nums is equal to 1, 2, 3, 4. The suffix will be 24, 12, 4, and 1. That means starting from 3, 2, 1, 0. Oh, we are now going back. The suffix will come down. The prefix will build towards up. Okay, so in position 3 here, we multiply everything except what is here. That means multiply 1 times 2 times 3. What? Okay, what? Which one? Let me see. Let me understand, right? Which one is the number we are picking here? Which number is I? Which number are we supposed to pick? Because I'm kind of getting confused now. So think of keys standing in a line. Pick 3. Left of 3 is 1, 2. Right of 3 is 4. Okay, so the product is 4. You never multiply 3 itself. You just ignore it. So how are we? Oh, God. Can I ask AI why we have 24 here? Let's say here we don't include 4. Nothing after it. This is what suffix, nothing after it, it remains as 1. Oh, so no matter what, it will always remain as 1. Okay. And then in position 2, we have 4. Position 1, we have 3 times 4. Position 0, we have 2 times 3 times 4. Oh, now I understand. I think when we are building the suffix, then we have to change these positions. Then zero becomes the position of 4, 1 becomes the position of 3, yes, and then 2 becomes this 2, and then 0 becomes this 1. That's why nothing after 1 here, nothing after this 1, so we leave it as 1. And then the position of 2, it is now multiply everything except this, right? So this is 0, 1, I mean 0, 1, 2, 3. Yes, that makes sense. That makes sense now. Oh my god, I had a hard time understanding this. Okay, suffix never includes I itself. My multiply prefix times suffix. So now the fun part for every index. Answer in position I is equals to prefix I times suffix I. Then we have 1, 1, 2, 6. That is the prefix, and then the suffix is 2, 12, 4, 1. Then the answer will be 1 times 24, 24. 1 times 12 is 12. 2 times 4 is 8. And 6 times 1 is 6. Then we get this. Wow. Oh, now I get it. Now I get it, boys. Now I get it. So let's try to include it here in our solution, right? Let's try to how can I pick this? Okay, just like this. Let me grab these ones. Let me, oh god, how can I take this off? Okay, just like this, and I think I can just delete this like this. Hold on, where is the sticker? Yup. Take this off. Good. Take this off, 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 off. All right, so now when we try to solve this using that prefix something, I mean using the prefix multiplication and the suffix multiplication, we're gonna have here, this is now position I, this is the output that we need, right? The output should be 48, 24, 12, 8. And this is 1, 2, 4, 6. So we are multiplying everything except itself. But now let's try to dissect it into 1, 2, 4, 6. Now let's try to build the suffix out of this, okay? I mean, we can start with the prefix actually. The prefix is now going to be, let's give these ones 1. Prefix will go from small to big, and then suffix will go from big to small, right? Yep, that makes sense. So 1, 2, 3. Index 0, index 1, index 2, index 3. So now for the prefix, we have to start with dividing this, right? Now let's say we want this element here. Okay, so if we say, let me just select anything, matter of fact, let me just select 2 for now. Let me select 2, right? So 2 is I, let's say I is equals to 2. I is equals to 2, that means we need to build out this prefix. Then we have to ignore everything on the left. So for the left of this, and then this is going to be the suffix, this is going to be the prefix. But I feel like, okay, this is fine, this is fine. So the prefix here is going to be 1, right, which is just the prefix, and then the suffix is going to be 4 and 6, isn't it? Oh, there's something wrong we're doing. I don't know. Is there anything wrong we're doing? Because if you can see here, right, we are building the suffix products. So this is the suffix products. If the numbers is 1, 2, 3, 4, we are saying prefix is 1, 1, 2, 6, right? Yep, and then the suffix will look like this: 1, 2, 3, 4. Then we'll continue building this. Okay, so we are building from the same array, right? We're building from the same array. That makes sense now. Okay, so let's consider this. That means we have to, let me just ignore the last one here, right? So for the prefix, there is nothing before this number here, before this 1, so we'll leave it as 1. And then 2 will be 2 times 1, which is 2. And then 4 will now be 1 times 2 times 4, which will be 8. And then 6 will now be 1 times 2 times 4, which is, hold on, 4. If we are on 4, then it is 1 times 2. Wait, hold on. This is 1, and then this is 2 as well. So 4 will now be 2 times what? 1 times 2. It's confusing me completely. My brain is fried right now. Jesus Christ. Oh my goodness. What are we doing, boys? Am I breaking it down properly or I'm not? I don't know. So this is index 1, the index 0. So index 0 will remain 1 because there's nothing after it. Before it. Since we are dealing with prefix, right? We need to consider it like this. Nothing comes before it. Okay, we leave it as 1. And then 2 will, in position 1 now, will be 1 times 2, and we'll leave it as 2. And then 4 will now be 1 times 2 times 4, 8. And then this one will be 1 times 2 times 4 times 6. Then we get 24. Is this correct, bro? Wait, is that correct? Let's check. No, it's not correct. It's not correct. Oh, God. Okay, let's see. 1 is just 1. So 1, we have this will nothing before it. It defaults to 1. No matter what number it is, it will just be 1. No, it will just remain that number. And then this one will be 1. 2 will be 1 times 2 is 2. 3 will be 1 times 2 times 3. Oh, you just multiplied with the prefix? Okay, let me try to do it here. Okay, let me try to do it here so I can understand it. Let me remove this naive approach for now. Okay, I'm just gonna remove this entire naive approach, and let's try to get that prefix sum, right? So we need to divide this into product. Oh, that answer, right? What are we doing? We are getting output I. Output I will be the product. Oh, prefix product, right? Prefix product times suffix product. Okay, I think that's all we have to work for. Then we can come here and say in position position 0 is 1, so we just multiply 1. We leave it as 1 because there's nothing before it. And then in position 1 here, we just multiply 1 times 2. 1 times 1 actually is 1 times 1 and remains 1. Yes, that makes sense. This one will remain 1. And then this one will be 2. That means multiply 1 times 2, which will be 2. And then this will be 3. You multiply 1 times 2 times 3, and then we'll get 6. Yeah. This is the prefix sum. The prefix product. God damn. And then the suffix product will now be 3, 2, 1, 0, but coming downwards. So we shall have now 3, 2, 1, and 0. And then if I is 3, that means go ahead and multiply. There is nothing after it. This is now suffix. So we'll leave it as is, which will be 6, right? Is it the same thing that we have for the suffix? Let's look at the suffix. Suffix is 1, 2, 3, 4. Then at 3, we leave it as 1. Also, anything that has 1, we leave it as 1. Anything that has nothing after it, we leave it as 1. How is the suffix working? This is 1 0 1 2 3. Oh, so 0 starts from this side. Wait a minute. So 0 0 is what will be this. 6 will now be 0 in terms of suffix, but for the prefix 6 is 3. Alright, bro. God damn, bro. How complicated can these things get? Oh my lord. Okay, fine. 3 will now be, let's look. This will now be 3 2 1 0. No, this will now be 0 for the suffix. Will be now 0 1 2 3. So we start from here. This will be 6, and this 1 will now be 4, and then 2 will be 2, and then 3 will be 1. So when we want to get the suffix product, we are going to have 3 will remain as 1, right? We can have it 1 because there's nothing after it, and then 2 will be 2 times 1, which will be 1 as well. Is it 1 or 2? 2 times 2, I think, is 4, and then 1 times 4, which will also be 4, and then 6. Holy cow, bro, this is confusing me beyond anything else. Nothing after it is 1. 2 will now be 4. Lord, how can this get me confused? Okay, we are at 4 now. Multiply everything except 4. So we're gonna have 2 times 3 times 4. Is that even true? Bro, break it down for me more. Break it down. Break it down for me. Father. The suffix changing indices is confusing. Bro, I've never been this much. Bro, I can literally sit down and solve for you calculus right now. Calculus 1, 2, and 3 without any problem. Only to come and find hardships with this, bro. Perfect. This is confusing. This confusion exactly where most people get stuck. So let's slow it down. All right, let's understand. The word is doing psychological damage. Replace it with the set. I'm working from the right end of the array and keeping a running product of numbers I've already seen. No indices gymnastics. I'm working from the right end of the array and keeping a running product of numbers that I've already seen. So if the numbers are 1, 2, 3, 4, the indices are 0, 1, 2, 3. The array we will use, okay? Yes. What suffix really is? The product of everything to the right of the index I. So the right of index 3 has nothing, so we replace it with 1. Okay. Even if the number is 10 here, it will just become 1. All right. Then the right of index 2 is now 4. Yes, that's true. What's on the right here is 4. Yeah, makes sense. What's on this the right of this index is 4. Okay, that makes sense. Now the right of index 1, it is 3 and 4. Okay, makes sense. The right of index 0 is now 2 3 4. Okay, now it's clicking. Let's now build it up step by step in slow mode. Okay, suffix, this is now empty, and then we'll also keep a variable. Right product is equals to 1. That variable means product of everything I've passed so far from the right. So start at the last index. I is equals to 3, which is what we have here. Okay, I is equals to 3, that's true. And then right of index 3 is nothing, so the right product is equals to 1. That is true. That is true. Because if we had placed it as 0, anything times 0 will be nothing, and it doesn't make sense, right? To be 0, and multiplication will start from 1 times this, 1 times that. Okay, all right. It's now clicking. Okay, now suffix 3 is equals to this is now 1i. Then update right product is equals to product right product times nums in position. That 3 in that position. Okay, then the product will now be 1 times 4, which is 4. So the state now is suffix is equals to whatever that's here 1. The right product is 4. Wait a minute. Wait. The right of index 3 is nothing, so the suffix is 1. Then we update product times these nums, we get 1 times 4 is equals to 4. Now the right product is 4, but the suffix is what we need, which is 1. Okay, so let's move left one step. We move I is equals to now 2. Instead of 3, we are moving downwards. So that means we're decrementing the index. Hi mate, I'm from India. My Python is done. What can I do next? wait. What? Did you just say my Python is done, bro? What do you mean your Python is done, bro? That comment made my day. I think this is my favorite comment, bro. Let me go and pin it. I love this comment. What do you mean your Python is done? You're so funny, brother. What do you mean your Python is done? I love this comment. Your Python is done is funny, bro. But yeah, if you mean you're done with Python, what should you do next? I'd say maybe go and did you try applying for jobs, or what's your field? Are you in AI, machine learning, or whatever? I'm a demon. I'm not a demon, bro. You're just a funny person. I'm trying to understand something here, okay? I'll focus. Just give me 1 second. Let me try to understand this. I'll get back to you. Right of index 2 is 4, and then we already stored that in the right index, or in the right product. Alright, then the suffix 2 will now become right product is equals to 4. Then now 4 times nums 2 is 12. Okay, now we have 4. And then the right product is 12. And then we'll move now to the left. Just like that, the right of index is now 3 and 4. And then the suffix is 12. Therefore, we multiply 12 times this is 24. And then we keep going until when we get 48, I think. Oh, it's 24. So this is 0, then 24 times 1 is 24. Then we get 24, 12, 4, 1. Now, why the index movement makes sense, here's the mental model that fixes everything. When you're on right index, this already contains this, so now some is this, you just move it to the left. Okay. All right, I kind of understand that part. So multiply them, and then you get prefix I times suffix I is equals to product except self. All right. Okay, so how can we put that into context now? How can we put that into code? That is now the challenge. So can we try to loop through this once? Then we say int I is equals to 0. Then for I should be less than nums dot length. And then I plus plus. Use lit code. Okay, fine. I'm using lit code now, but I can use lit code as well. So I feel like there's no difference really, for sure. There's no big difference like that. Still the same thing. Bachelor of Computer Science. Wait, Bachelor of what? What is BCA? Computer Science student. What's BCA? It's kind of confusing to hear, for sure. So here's the thing, right? I think this one was working, if I'm not mistaken. Yeah, we solved it yesterday. I was just using this to understand it better. Okay, we solved it already. As you can see, we have int now n is this the length, and then we create a result array that is storing our result, and then it's going to store the length of that array. It's going to be an array of fixed size, depending on this length. And then we have int prefix. Prefix product will be 1 because we are starting with 1, and suffix product also will start by 1. Then we loop through first this I less than n, and then we loop through this, but we are now decrementing for the suffix. But the product we are increasing. So we have result of I here will now give us the prefix product. Yo, what's up? What's good, man? Hey, bro, how are you, man? I hope you're fine. I'm very fine, brother. I'm very fine. I'm cool. I'm doing good. I'm doing great, brother. Yo, Real Ahmed Mughal, computer application. Oh, my boy Amir, what's up, man? I haven't seen you in a while. What's up? What's good? Bachelor of Computer Applications. Computer applications. Wait, there is something called computer applications? I've never seen that. I've never seen that. What's happening here, chat? What's happening there? We have a brother who left my favorite comment here. He said, yeah, I can read this comment. He said, hey, mate. I think he meant mate, not mate, like mate, literal mate. He meant hi, mate. I'm from India. My Python is done. What can I do next? Dude said my Python is done. Why not use prefix and suffix arrays? It will make an easier solution. I'm doing good, brother. Wait, how many of you guys are doing lead code, man? I'm feeling like I'm alone here. Can you guys just join me and we do lead code together every day, bro? Who are those guys doing lead code, bro? Yeah, let me know. I should search on Google. I'll look it up. Bro, where you from? I'm from South Sudan, bro. I'm from South Sudan. You're doing good, brother. Amir, that's my brother, man. That's my broski. I haven't seen you post a video in years, though. Last time I checked, you had uploaded a video. I don't know. Let me see. Yep. Have you uploaded anything yet? Which language is the best? Java, brother. Java is the best. Hi, brother. Yo, what's good, man? How you doing? What's that name? Okay, hello. Buvnish. That name. Hello. Buvnesh. Bove or Bov. Bro, your name is hard, man. Your name is Patel. I'll just call you Patel, man. Your name is super hard. Yeah, you haven't uploaded. I think you last uploaded 2 weeks ago. I think you were busy with exams or something like that, right? Hello, Bahe. What's that? You from India? That's interesting. I'm from South Sudan, bro. Again, brother, please. Please, what? What do you want me to say? Can you give me tips on Java? Okay. A lot of people ask me that question, right? And fun fact, you guys, there's no tips that somebody can give you and say, brother, take this and go. That is the end result. No. Just code every single day. That's the only thing. Build projects. No, that's very generic because everyone says it. But how can I break it down for you? If you use this roadmap.sh, it will give you everything you need. Like, for example, right now I'm doing a Spring Boot. I'm done with almost everything here except microservices. Now, let's assume I want to start with microservices with Spring Boot. This is what I'll do. I'll go to microservices, understand everything from here, and then read all these articles. But officially, microservices with Spring, I can read this and understand the docs. And then, like, I love to just code depending on what I need to use. You get it? I don't like Java, man. I like Java. Oh, okay. Pronounce my name. Yeah, I'm busy graduating some embedded system because I needed to start applying for jobs soon before graduation. Yeah, man. Yeah, for sure. My boy's name is your name is hard, bro. I'll just call you Patel. It's okay. Wait, Amir, did I just hear you want to apply for jobs before graduation? Are you graduating this year? Are you done or still? Yeah, man, the chat be going crazy, bro. My brothers be going crazy in the chat. I'll be going crazy in the chat, bro. So let's see. Okay, now let's say solve it with Java. With Java. Alright, let's get straight into it and then try to see what's going on here with Java. Yeah, we have that. We first define the length and then we create a new array result that has the length in it. After that, we start with the left product, which is the prefix product. Then we say these will be left product. Obviously, we are starting with 1. From the left, we start with 1, and then we multiply the left product times left product times this. So we are going to get left product times itself. Then it will give us nums I. And the same applies to this, but we are decrementing every time. So I will now be n minus 1. As long as I is greater than 0, then we decrement this every time. And then result I will now be result I times itself. Then we shall get this. I think it will make sense. Yep, I'll be graduating in June, man. I started the final semester in January. I previously... Wait. Oh, you will start in January. I previously competed in an internship. You completed an internship? Wow. So guys here in the chat have jobs and I'm jobless. Why you guys not giving me a referral, man? We'll go take the product of all elements to the left, multiply in the product of all elements to the right of I. BTech student? Yo, bro, listen. Why can't you guys, somebody here is using Hindi in the chat. Come on, bro. Speak English. Type English. Only English allowed. What are you guys talking about? Delhi? Wait, I think Delhi is the best city in India, man. I love Delhi. I've heard about it a lot. Delhi. How many cities are there in India, bro? There seems to be a lot. India's capital. Oh, wait, New Delhi? There's New Delhi and Old Delhi. What about Bangalore, though? What is Bangalore? Bangalore. I think it's like this. Bangalore. Wait, this is not. Oh, Bengaluru, commonly known as Bangalore. Okay, it's like this, Bangalore. Somebody said somebody said Delhi is not good for serious students. Why? Hyderabad? I think I have a lot of friends from there. I have a lot of friends from Hyderabad. These names are hard. Hyderabad. Look at the images. Oh, bro. I didn't know India was fire like this, bruh. Yo. It's Bengaluru. Okay. Hyderabad is good. I think I'm you in Hyderabad, right? If I'm not mistaken. I think you're in Hyderabad. Noise pollution and it's too crowded. Where? Yes, crowded. Hyderabad is too crowded. Wait, who said somebody's IQ? I want to do internship. Give me a reference on it. Okay, no problem, brother. Nope, I'm from Chandi. Oh my god. How many cities are there? Let me first ask. How many big cities? Big cities are in India. How many big cities are in India, bro? I really want to know. Let's focus on lead code, man. I will, bro. Calm down. Give me a second. We're trying to take a little break, okay? We've been streaming, for quite a long time. Relax, calm down. How many big cities are there? Let's look at this. India has around 75 cities with population exceeding 1 million people. Hey, that's a lot of people. That's a lot of people, brother. All right, not bad, not bad. Let's get back. Let's get back. India is the fourth largest economy. Hello, brother. What about tech jobs in your country? They are so trash, bro. They are so trash. In this, oh my god. Do you know how much they pay a software engineer here? $9,000 a year. Now, $9,000 a year, if you multiply it by 12, I mean, divided by 12, that's like, I think about $500 a month, something like that, which is too fucking low, bro. Yeah, that's too low for a software engineer, bro. You feel me? We cannot accept that. Yeah, it's so sad for sure. It's so sad. It's so sad. Okay, so now here I have a question. I have a question here. Let's try to focus. Let's try to focus here. We are multiplying result times result again, and then is it considered a product? The right product? Oh, hold on. We have this result I that already has that will multiply right product. Now I have a problem here. So let's say explain why we multiply result I within the suffix but not. Yo boys, I've already answered this question, but I just want to understand it, that's why. But not within the prefix. Okay, let's see. That's not too bad for a fresher, to be honest. $9,000. Why do you guys are the ones spoiling the market? If you're ready to accept $9,000 a year, bro, you are going to spoil the market. Don't do that. Don't lower your pay for just the sake of like. I feel like, yeah, if you really want to just get the experience, I think that makes sense, right? I think that makes sense. My LinkedIn? Okay, let me send you guys my LinkedIn. I think is inside my GitHub. Let me send you guys my LinkedIn so y'all can check it out. Wait, what is AQI? What is AQI? What is AQI? I don't think so. Brother, I send you a LinkedIn request. Please follow me back. All right, let me click my LinkedIn. Hey boys, I didn't tell you guys I have my portfolio ready. We have our portfolio ready. Air quality index, okay. We have the live demo for the app. We have everything here except these other ones. These other ones are not, they are trash. They are trash projects. So I have only these good ones so far. Okay, you sent me a LinkedIn request. Let me go check it out. Oh yeah, you see that? Pollution, brother. Amazing. Yep, so this is the LinkedIn. I didn't see you here. I'm not seeing you, my brother. I think you sent the wrong person. I think some college placements give that package 8 LP, which is equivalent to $9,000. Yeah. Okay, I think that's fair enough. I feel like maybe, I don't know, maybe expenses there are very, because here, like, bro, month, like, let's say $10,000 a year, bro, is $9,000 a year is not it, bro. It's not it. Unless you really want to get the experience, just. I would say, yeah, if you want to get the experience, then just go for that. Otherwise, if you want to change your life, bro, that is not that. It's not going to cut it, man. It's not going to cut it. Hey, boys, go ahead and like the live, bro. What are you doing, bro? You watching me and you're not liking, bro? Come on, man. Come on, bro. Come on. Let's go. India has strong purchasing power. Wait, India has strong purchasing power, but why are they not paying their engineers highly though? Because it is ironic, like the payment in India is very low, if you ask me. For real. It is more than enough for a fresher in India. Oh, for real? Oh my god, I'm coming to India. Wait, how much is rent there? How much can you rent a house in India? Like a house, 1-bedroom apartment. Could be a studio apartment, just having your kitchen, your room to sleep in. How much is it? Okay, so this one, once it clicks, it really clicks moments. Let's dismantle it. What results I means at this stage, meaning result I changes over time. That's the entire answer in one sentence. So result I is equals to, during the prefix pass we have, is equals to the left product. Left product is, okay, we just multiply left product now to get this. At this point in the algorithm, result I is empty. It does not contain any useful information yet. We're assigning, not multiplying. Why assign makes sense here. Okay. Also, we first assign this to be this, the left product. So whatever is on the left, we don't really care what it is. There is nothing already inside this, so we just need to preserve this. So result I is equals to product this. So if we multiplied instead, result I is equals to this, we would be multiplying garbage, default 0 and get garbage. That is correct, that's correct. Depends upon the location. Around 35k in Bangalore for 1 month for a decent life. Wait, then how much do you need though? Let's be honest, like, let's say right now, how much do I need to be earning in order to afford a 1-bedroom house in India? How much do I need to be like earning in order to afford that house? You know, a house comes with amenities, so you just include things like Wi-Fi, internet, power. Wait, I just said Wi-Fi and internet. I say Wi-Fi, power, whatever, water, anything that is within the package. Just put it all together and tell me. We pay 16k for a 2-bedroom house, 2 BHK, which is 2 bedrooms, right? Which is less than 200 USD, fully furnished, depends on the location. Yo, no way, bro. No way, bro. Hold on, let me stretch myself. Let me stretch. I don't believe that. I don't believe that shit. Oh. Yeah. I don't believe that shit. I don't believe that. $200, less than $200, you're getting a 2-bedroom house, fully furnished. Nah. I need to come to India, bro. How much is a ticket to India? Hold on. A ticket from Kigali to India. Bro, I need to know for real. I need to know, bro. Y'all make me come there, bro. And if I get disappointed, I'll come in for you guys. That's like $500. It's not bad, bro. It's like, yeah, given you guys are 3 hours ahead, it's worth it, right?